this is kind of our little tool chest. We've got one batch fermenting right now. It's about 10 gallons. And then some of our brewing gears right here.
Patrick Schwing is trying to brew the perfect beer. When he's not at work, he's tinkering with vats and bottles in his garage, or on a makeshift workbench in his backyard.
It's one of my favorite sounds right there.
He says that making a good brew is all about experimentation.
You know, when you start off brewing, each step of the process, you play with certain times and certain temperatures and certain ingredients.
In other words, it's the same sort of thing he does in the lab. Schwing is a chemical oceanographer at the University of South Florida, where he studies single-celled animals that live in and around the sediments on the ocean floor. They're called foraminifera, or forams for short. Although they're microscopic, they can tell scientists a lot about the health of the world's oceans.
They're kind of like the canary in the coal mine. They're usually the first ones to react to changes in their environment.
After the Deepwater Horizon spill in 2010, the environment at the bottom of the Gulf of Mexico changed dramatically. More than 5 million barrels of oil spewed into the water from a broken wellhead. It killed fish, marine mammals, and countless forams. Schwing is using those forams to understand the long-term impact of the spill. To get them, he and his colleagues spend weeks at a time on a research ship, pulling samples up from the ocean floor with an instrument called a multicore.
Looks like a lunar lander, and it has 8 tubes that stick out the bottom of it. We send it down to the bottom, and those 8 tubes push gently into the sediments. And then we carefully bring it back up on board and pull those tubes off of the multicore.
Many of those samples end up here in Schwing's lab, where he analyzes their chemistry and sorts the forams inside them under a microscope.
So we flip on the light and grab a paintbrush here. Tools of the trade, you know. So basically put a small portion of the sample into this tray, and then under certain magnification you can pick out individual species and genera. By looking at the total number of forams that are in the sediments and the types of forams that are in the sediments, you can get a really good idea of how toxic an area may be.
It's painstaking work, but it's helping Schwing understand how the spill affected the Gulf on the whole. In some areas, he says, forams died out entirely, and even years after the disaster, they're still slow to come back. That means the Gulf ecosystem could take decades to recover. For Schwing, doing science isn't just a job, it's more like a lifestyle. In the garage behind his house, he's built a sort of personal lab, a place where he can relax and think about his next experiment, or his next brew, or even play with new musical ideas for his band, the Funky Seeds. He says the way he approaches his hobbies isn't so different from what he does in the lab.
If you're trying to refine your ability to do something, whether it's a sport or whether it's brewing or playing music for that matter, you know, it's all about experimentation. The more I learn, the more questions I have. And I think that's what's really fun about science, is chasing down those questions and trying to answer them the best we can. For some reason, you know, in the lab it feels like work, and in the garage it feels like a hobby. You know, I don't know, but it's the same process. It really is.